is known as Newton's first law of motion. Okay. Newton's first law of motion is also known as law of inertia. Why do we call Newton's first law of motion is law of inertia? Yeah, in the previous class we learned that inertia is nothing but to oppose the change, to resist the change. And we also learned that inertia depends on mass. Larger the mass of the object, larger will be its inertia. Fine. We learned that there are three types of inertia. They are inertia due to rest, inertia due to motion, inertia due to direction. Inertia due to rest, that is, the tendency of the body at rest remains at rest. For example, a passenger standing in a stationary bus, when the bus suddenly starts, the passenger falls backward due to inertia of rest. Inertia of motion, that is, the tendency of a body in motion remains in motion. The tendency of a body in motion remains in motion. For example, a passenger sitting in the moving bus, okay, falls or hits the front shield when the driver of the bus suddenly applies brakes. Okay, a passenger sitting in a moving bus, he hits or he falls forward when the driver of the bus applies the brakes. That's due to inertia of motion. Inertia of direction, that is, a body moving in a particular direction keep moving in that direction only. That is inertia of direction. In a motor boat, when the direction of the motor boat changes suddenly, the passengers who are sitting in the motor boat, they go to the other side or they fall into the river because of inertia of direction. I repeat the example. When the motor boat takes the direction suddenly, changes the direction suddenly, the passengers sitting in the motor boat, they move out of the place or they fall into the river due to inertia of direction. Fine. So all these together, Newton put in the form of a law, which we call it is law of inertia or Newton's first law of motion. According to this law, it states that every object in a state of rest or state of uniform motion continues to be in the same state unless and until the object is compelled by an external force. I repeat here, every object in a state of rest or in a state of uniform motion along a straight line continues to be in the same state unless the object is compelled to change the state by an applied force. In simple words, I explain. The object which is at rest remains at rest. The object which is in motion remains in motion unless and until an external force acts upon the body to bring that change. Newton's first law of motion. Since this law is involved with inertia, so it is called law of inertia. And all the examples of inertia are the examples of Newton's first law. Okay, so this completes about Newton's first law of motion. That is, everybody in a state of rest or in a state of uniform motion continues to be in the same state unless it is compelled by an external force. Okay. Then coming to Newton's second law, which is known as law of momentum. Okay. Before that, let me tell you the meaning of momentum. What is momentum? How do we explain momentum? And what are the factors on which momentum, is it scalar or vector quantity? What is the SI unit of momentum? So let us learn about momentum in a detailed manner. Fine. As we know that momentum is the motion contained in a body. The amount of motion present in a body, the amount of motion contained in a body is called momentum. Okay? For example, when a bullet is fired, due to its mass and velocity, bullet has large momentum. Even though its mass is less, but it has a very high speed, it has a great speed, great velocity. So its momentum is large. Larger the speed, larger would be the momentum. Larger the mass, larger would be the momentum. So momentum depends on two factors. Before that, let me tell you the expression or the mathematical form of momentum. Momentum is equal to product of mass into velocity. Momentum is equal to mass into velocity. Momentum is denoted by a symbol P. P is equal to m into v. P is equal to m into v. Okay? P depends on two factors, mass and velocity. If mass is more, momentum is more. If mass is double, momentum is double. If velocity is double, momentum is double. If velocity is halved, momentum is halved. So momentum depends on two factors, velocity and mass. Okay, fine. Momentum is the motion contained in a body. As we increase the speed of a fan, electric fan, its momentum increases. When a cricketer picks up a ball and then throws, the ball will have momentum. An athletic, when he throws a javelin, the javelin will have a momentum. Any object that is moving will have momentum. So what is the impact of momentum? That momentum will have a cause or will have an impact on the other object. For example, if a person is standing on the road and a car comes and hits, that person will die or he will get severe injuries. He will receive severe injuries because of the momentum of the car. But when the same car is at rest, even though it has mass but velocity 0, its momentum is 0. It doesn't have any effect on other object. But when it starts moving, it will have momentum, and that momentum will be transferred to the resting body. Therefore, that resting body will receive the damages. Fine. So momentum is equal to mass into velocity. This momentum is a vector quantity. It's a vector quantity. It has direction. What is the direction of momentum? The direction of momentum is in the direction of velocity. As we know that velocity is the rate of change of displacement. Velocity is a vector quantity. The direction of velocity is in the direction of displacement. Since velocity has direction, momentum also has direction. And what is the direction of momentum? The direction of momentum is in the direction of velocity. So, in higher class we write that. We write like this. It means that momentum is a vector quantity, velocity is a vector quantity, but mass is a scalar quantity. Yes, this Newton's second law is related to momentum. Newton's second law is related to momentum of a body. This momentum, it changes when the force applied on the body changes. Okay? Say for example, a body moving with a velocity u, whose mass is m. M is the mass of the body, and body is moving with a velocity u. If suddenly an external force, a constant force is applied, when the constant force is applied on the same body, what will happen to its velocity? Its velocity increases. Its velocity changes. So this is V, final velocity. This arrow mark, the length of arrow mark gives the magnitude. Here it is moving with some velocity, whose velocity is less. Suddenly when the force is applied on this body, velocity increases. This length of arrow mark is more, therefore its velocity is more. It means there is a change in velocity here. There is a change in velocity. What is the change in velocity? V minus u. When the velocity changes, momentum changes. What is the initial momentum here? mu. Mu, mass into velocity, because the object is moving with some velocity, whose momentum is m into u. What is the final momentum? Mass remains same. There is no change in mass. Only there is a change in velocity because force is being applied. So final momentum is mv. This final momentum minus initial momentum is known as change in momentum. So I write this change in momentum of the body is equal to change in momentum of the body is equal to mv minus mu. Why this change in momentum? This change in momentum is because of force, because of that applied force. Fine. Then, as the force continues to apply in the body for a time t, then there will be change in momentum with the time. As the force continued to apply momentum with a time, we call it is rate of change of momentum. Okay, I'll write that. Rate of change of momentum. Rate of change of momentum. How do we write? We write it is mv minus mu by t. The force is being applied constantly on the body, and there is a change in momentum of the body with a time, which we call it is rate of change of momentum. If the force changes, then momentum also changes. So rate of change of momentum means for every second, for every moment, there is a change in momentum, which we call it is rate of change of momentum. As the force applied on the body increases constantly, then momentum, that is change in momentum with the time, also increases. If there is a decrease in force on the body, then there will be decrease in momentum. That is also called rate of change of momentum. So, the rate of change of momentum of the body, it depends on force. Suppose if I apply on a stone a larger force, then there will be a larger momentum. If I apply a smaller force, there will be a smaller momentum. So, momentum of the body, it depends on the force applied on the body. So, we can write that rate of change of momentum. Rate of change of momentum of a body is directly proportional to force acting upon the body. Force acting upon the body. In other words, force acting upon the body is directly proportional to rate of change of momentum. Both are same. Change in momentum of the body depends on the force applied. Okay? Or the force is directly proportional to rate of change of momentum. I can write that. Force is directly proportional to rate of change of momentum. Force F is proportional to rate of change of momentum, that is mv minus mu by t. I write mv minus mu by t. Yes. No, I will continue this derivation here. Here I will continue. Force is directly proportional to rate of change of momentum. M is taken common here. M is taken common here. M is the mass of the body. Mass remains same. Only the velocity changes as the force applied in the body changes. Greater the force, greater the velocity. Okay. F is proportional to m. Change in velocity divided by time is known as acceleration. Change in velocity divided by time is known as acceleration. That means when the force is applied on the body, acceleration is produced in the body. So greater the force applied on the body, greater would be the acceleration. So acceleration produced in the body, it depends on the force applied on the body. So F is equal to some constant into M into A. This constant is known as proportionality constant. Okay? So this value of K is 1. Then F is equal to M into A. So we got a new definition for force. What is force? Force is the product of mass of the body and acceleration produced in it. Mass into acceleration is known as force. This force is equal to mass into acceleration is simply called Newton's second law. Greater the force applied in the body, greater would be the acceleration. But this derivation of F equal to ma is very important. Right? From this we can define what is 1 Newton of force. 1 Newton of force is equal to 1 kg into 1 meter per second square. If 1 Newton of force is applied on a body of mass 1 kg, an acceleration of 1 meter per second square is produced in the body. In other words, force is said to be 1 Newton if an acceleration of 1 meter per second square produces in a body of mass 1 kg. So this is about Newton's second law.